Hello everyone. In today's video we are going to go over what we have been discussing in Computer Science 112, mainly Tuesday's lecture, August 29th, 2022. So in Banerjee's class we went over something similar like this, but I made this a little more simplified, that way you guys can have a better understanding. So without further ado, let's get started. So first we have our C++ program, which goes into the compiler, which goes into the CPU, which does the instruction we need to get our solution. So the first part of our instruction is our int type. This int type is made up of 4 bytes, which is going to be displayed right there. Now the second part is these question marks. What do these question marks mean? This basically tells us that we're not going to initialize our memory. Now the next thing you guys are going to go over really soon are registers. You guys need to know what registers are. So this is basically an EAX register, which is just a box that we can use to store variables or numbers of a certain size of bytes. So now as we move on to the instruction, we have 45 and we're putting that inside the register EAX. So we're putting 45 in the box, which is just like we put 45 into the variable x. Now the next part of this instruction is to do x is equal to x times -1, which is basically making this number 45 negative. If we look at the second box down here, here's the instruction to make 45 negative. So first we have 45, we need to convert that to binary. So the binary number for 45 is going to be 0101101, and then we have to prove the 2's complement of this binary number. And in order to do that, we have to first do 1's complement, which is just flipping the bits around. So when we flip everything over, we have 1 0 1 0 0 1 and 0. And then next part is just to add 1. I made this easily convenient, that way we don't spend 5 minutes just carrying. So 1 plus 0 is going to be 1, and then we just 0 0 1 0 1. So the next part of this is just to take this number and we're going to convert this binary number into hexadecimal form for our convenience. Because when we put this binary number into the stack, it's going to contain 32 bits, which is just 32 binary digits, which is going to be hecka confusing for us. So we need to convert this into hexadecimal form. Now we only have 7 binary digits. We need 8 to convert this to hexadecimal. But we can't add a 0, we need to add a 1. The reason why we add a 1 is because we need to look at our significant digit. This tells us whether our number is positive or negative. Since it's 1, it's going to signify that it's negative. Now when we convert this to binary, we did this during class where I also posted notes. We're going to convert this to binary, so we have 8421 and then 8421. And then we need to grab the 8, the 4, the 1, which is going to be 13. And then I believe the letter for that is going to be D. So for the next part, we're going to grab the 2 and the 1, which is going to be 3. And this is going to be our hex. But remember, this is 8 bytes, so we need to add 2 zeros at the beginning of our hex digits. That way we have the correct size of bytes for our stack. Another thing we need to remember is that we need to put this into little endian form. So in order to put it into little endian form, we need to take the last 2 digits, and that's going to be the first, going to be put in the first square of our stack. And the other bottom square is going to contain our 2 zeros that we had beforehand. And now when the Intel chip reads this, it's going to spit out 00D3 just like we originally had. Now for the rest of these boxes, we're just going to put question marks because we didn't know what instructions came before our 45. And we're so just going to put question marks. That way we know there's something there, we just don't know what it is. Now when we do the storing in little endian form, it also affects how we do our instruction. So now our next instruction is going to be EAX, which is also going to contain binary digits. We don't know exactly what that is. We can say it's just 001 for now. But later on, we're going to realize that when we have these instructions inside the stack, they're going to contain their own binary digits as well, and we can convert that to hex. So whatever instructions we put inside the stack, they're always going to have binary digits. And same thing with this MOV statement. This MOV statement is also going to contain binary digits we can convert to hex, which is going to be inside our stack. And this is exactly how our stack is going to perform. That way our CPU performs the task that we need it to perform. And the same thing is going to happen with our cout statement. As we have seen in this third and final box, it's also going to contain stuff just like what I've discussed earlier. And that is going to wrap up this video. Thank you for watching. Again, if you guys have any questions about anything I discussed in this video that didn't seem clear to you, I'm in the Discord. You can ask questions. And I'll see you guys around. I'll see you guys in class tomorrow night, I believe. Yep. All right. Bye.